e raised to 0 natin is 1 na yan. So this is 1 minus e raised to negative 20 x minus 12.5. Ito yung ilalagay natin sa cumulative distribution function natin, and this is for this equation here. 12.5 less than or equal x. Hi everyone, this is Ashley Guzman and welcome back to my YouTube channel. For this tutorial video, we are going to discuss a cumulative distribution function of continuous random variables. So without further ado, let's begin. An alternative method to describe the distribution of a discrete random variable can also be used for continuous random variables. And again, that is the cumulative distribution function. The cumulative distribution function of a continuous random variable x is given by this equation. F of x, or the cumulative distribution function, is equal to, say we have the probability equals the function of u du from the limits negative infinity to x for negative infinity less than x less than infinity. The cumulative distribution function is defined for all real numbers. So as we can see in the equation, nakikita natin sa first limit natin is negative infinity. But that doesn't mean na infinity lagi ang ilalagay natin kapag nagsosolve na tayo. So yung value ng first limit natin depends on any given value from the condition of the problem na may encounter natin. Example number 1. Let a continuous random variable x denote the current measured in a wire in milliamperes. Assume that the range of x is from 4.9 to 5.1 milliamperes. And assume that the probability density function of x is equal to fx equals 5 for 4.9 less than or equal x less than or equal 5.1. Find the cumulative distribution of the x. The cumulative distribution function of the random variable x in our problem consists of three expressions. Number 1, yung lowest limit natin of the value of f of x, which is 0, and yung greatest limit natin, of course, which is equal to 1, and yung in between na kailangan nating i-compute. So for f of x, which is a value of 0, this is for x less than 4.9. And dun sa in between natin, say we have f of x again, and using the equation, the integral of fu du, again, ang ilalagay natin sa lowest limit or sa first limit natin is 4.9. This is our lower limit. And ang ilalagay natin sa upper limit is x. So this is equal to ang value ng fu natin, or again, ng fu natin is simply, ito lang din yan, f of x. So ibig sabihin, ang value ng fu natin is 5. Yung 5 na yan ang ilalagay natin dito sa equation. So again, the integral of 5 dx na to from 4.9 to x. So calculating, this is 5x from 4.9 to x. And substituting the values, we have 5 starting with x minus 5 times 4.9. So f of x is equal to 5x minus 5 times 4.9 is 24.5. And this is for dun sa x na nakapagitan. For 4.9 less than or equal x less than 5.1. And finally, for f of x na equal sa 1, so this is for 5.1 less than or equal x. Ito yung ating main values na ilalagay sa cumulative distribution function. So, creating the cumulative distribution function, we have f of x equals, starting from 0 to this function, 5x minus 24.5, to this function, we have 1. For 0, we have x less than 4.9. For 5x minus 24.5, we have 4.9 less than or equal x less than 5.1. For the value 1, we have 5.1 less than or equal x. So this is the cumulative distribution function of the random variable x natin. Notice that in the definition of the f of x, itong f of x na yan, any symbol na less than, yung symbol na less than, can be changed into less than or equal and vice versa. That is, dito sa example na to, yung f of x natin can be defined as either 5x minus 24.5 or 0 dun sa endpoint na 4.9 dito. Yung f of x can be defined as either 5x minus 24.5 or 1 naman dun sa isang endpoint which is 5.1. So in other words, yung f of x natin kasi is a continuous function. For a discrete random variable, yung fx is not a continuous function. So sometimes a continuous random variable is defined as one that has a continuous cumulative distribution function. So this is example number 1. Example number 2, let the continuous random variable x denote the diameter of a hole drilled in a sheet metal. The target diameter is 12.5 millimeters. Most random disturbances to the process result in larger diameters. Historical data show that the distribution of x can be modeled by a probability density function given f of x equals 20 times e raised to negative 20 times x minus 12.5 for x greater than or equal 12.5. Find the cumulative distribution of the x. For this example problem, yung f of x natin consists of two expressions. Say, starting with f of x equals 0. So this is for x less than 12.5. So yung random variable x kasi natin is umiikot lang dun sa target diameter natin at 12.5 millimeters. That's why we have only two expressions. Para naman dun sa 12.5 less than or equal x, or kung i-reverse natin, this is x greater than or equal 12.5. So for f of x niyan, we have the equation, the integral of 20 e raised to negative 20 times u minus 12.5 du. Or simply, pwede natin ilagay is yung x na lang. From the limits, ang limit natin is starting from 12.5 up to x, the upper limit. Integrating the given function, so we let v equals negative 20 times u minus 12.5. Solving for dv, the derivative of this v, this is now negative 20 du, since this is 0 na. Since meron tayong 20 dito and du, solving for 20 du only, this is equal to 20 du equals negative dv. And next, we are going to substitute the values na na-solve natin from letting v and solving the derivative of v. This is now equal to the integral of ang e natin raised to ito, which is inilet natin as the v. So this is e raised to v. And yung 20 du natin, ito yan. This is now equal to negative dv na. From 12.5 to x. And integrating, this is now equal to, ilabas natin yung negative 1, since constant naman na siya, or simply negative na lang. The integral of ev dv from 12.5 to x. The integral of ev dv is simply ev lang din. So this is e raised to v negative from 12.5 to x. Let's continue here. Substitute na natin yung real value ng v. This is negative e. Ang v natin is negative 20 u minus 12.5 from 12.5 to x. And substitute na natin yung limits. Negative e raised to negative 20, we have x minus 12.5 minus, this is negative e raised to negative 20 times 12.5 minus 12.5. So this is negative e raised to negative 20 times x minus 12.5. Negative times negative is positive. And 12.5 minus 12.5 is 0. So 0 na to lahat. This is positive e raised to 0. And positive, and the e raised to 0 natin is 1 na yan. So this is 1 minus e raised to negative 20 x minus 12.5. Ito yung ilalagay natin sa cumulative distribution function natin. And this is for this equation here. 12.5 less than or equal x. Let's proceed to the next page. We have f of x equals, starting from 0 to 1 minus e raised to negative 20 times x minus 12.5. Yung 0 natin is for x less than 12.5, and yung function natin na to is for 12.5 less than or equal x. So this is our cumulative distribution function for the random variable x. For a practical interpretation, yung cumulative distribution function natin enables one to easily calculate the probability of the diameter in less than a value such as yung 12.6 millimeters. Therefore, the probability of a scrap part can be easily determined. So this is example number 2. The probability density function of a continuous random variable can be determined from the cumulative distribution function by differentiating or by solving derivative. So yung fundamental theorem of calculus states that we have derivative of the integral of fu du from negative infinity to x over dx, and this is equal to f of x. Then, given fx, ito, yung fx natin can be solved again by differentiating, and this is equal to the derivative of f of x over dx, and this is as long as the derivative exists. Example number 3, the time until a chemical reaction is complete in milliseconds is approximated by the cumulative distribution function given. For 0, we have x less than 0, and for the function 1 minus e raised to negative 0.01x, so that function is for 0 less than or equal x. So for this problem, ang gagawin natin is yung differentiation ng f of x, ito. And one by one, we will differentiate. Yun yung ilalagay natin sa cumulative distribution of f of x. So f of x, again, is equal to the derivative of f of x over dx. And ilalagay natin ito one by one and solve for their derivatives. For 0, of course, 0 na yan. So, ilagay na natin dito. This is 0 for x less than 0. And for the derivative of 1 minus e raised to negative 0.01x. So, this is derivative of 1 over dx, ito yon, minus a derivative of e raised to negative 0.01x over dx. So this is 0 na. For this part, this is eu du, and this is negative e raised to negative 0.01x. Derivative of u natin, ang u natin is ito, derivative of negative 0.01x. We have negative e raised to negative 0.01x. Derivative of negative 0.01x is 0.01 negative na lang. So this is magiging positive na. Ito, negative times negative. This is positive 0.01 e raised to negative 0.01x. Ito ang ilalagay natin dito sa part na to. So this is 0.01 e raised to negative 0.01x, and this is for 0 less than or equal x. This is the cumulative distribution function equivalent to the derivative of f of x, which is eto nga. And for the probability that a reaction completes within 200 milliseconds, when we say within, the random variable x natin is less than 200. So, ang gagamitin natin is, itong part na lang na to, since hindi naman na natin pwedeng substitute dito dahil 0 na yan, there is no function. For the probability of x less than 200, this is equal to function of 200, and substituting the value, we have 1 minus e raised to negative 0.01. Ang x natin is 200. Ito, this is 1 minus e raised to negative 0.01 times 200 is 2. And calculating the value, the probability of x less than 200, or the probability that a reaction time completes within 200 milliseconds is 0.8647. So this is the probability, and this is the answer for example number 3.